All right, so we are going to be simplifying radical expressions. And when we say expressions, meaning we don't have just one term anymore, it's going to be multiplying. So if we look at the first one, first what we want to do is kind of separate them in a sense of determine, okay, well, who needs simplifying? 2x squared times a square root of 3x, that's as simplified as it gets. Then if we look at the next one though, I have x to the 10th on the inside, and I know that can be simplified even more. So now I have my problem is 2x squared square root of 3 times x times 4, and there's 5 groups of x squared, so it's going to be x to the 5th, and nothing is left in the radical, so that went away. Now, when you multiply, everything on your outside multiplies and everything on your inside multiplies. Well, I only have one thing on the inside, so that's going to stay the same, but then I'm going to multiply my outside. Because I'm multiplying my exponents, the product rule, so I'm going to multiply 4 times 2, which is 8, and then add my exponents, which is not 10, that would be multiplying. My exponents are going to be 5 plus 2, which is going to be 7, and then I'm going to have square root of 3x. And because there's nothing else on the inside, this is my final answer. So if I go to the next one, I have a much larger equation, and I kind of want to work one by one. So first, I'm going to zoom in. I'm going to look at just this term because I know that can be simplified. I know square root of 4 is 2. So first, I'm going to rewrite my original outside because they didn't change. And then I'm going to have times 2 because the 4, okay, is going to come out to 2. I have 2 groups of x squared, so it's going to be x squared. And then I'm going to have another 2 groups of y, but I have 1 y left over. So when I break that down, this is my new outside. Now I have to simplify that, and I again add my exponents that are on the same base, but multiply my coefficients. So 3 times 2 is 6. Okay, I have 4 x's, I have 5 y's, and I have a square root of y. All right, times. Let's go to this second section. Now, if I look at this one, this also can be simplified. I still am going to have the 2y on the outside. That doesn't change. But then I am going to have 5x to the 5th because there's 5 groups of x squared. So there's 5 groups, so we have x to the 5th. And then I'm still going to actually have 1 left over. So I'm going to have an x. And then I'm going to have, again, 1y out here because I took one group of y squared, and that is going to still leave me with 1 extra y in the house. So if I really want to break it up and go really deep and you say, well, how did you get that? Okay, if we break this down, I have x times 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 x all the way to 11. And I grouped them in 2, or you could do x squared times x squared times x squared times x squared, okay, times x squared times x, and you realize all of these came out. So if you want to review my previous video for this, when we're just simplifying radical expressions. All right, so now if we're looking at this, okay, again, I multiply my coefficients, I add my exponents with my y's, they each have a secret little 1, so it becomes 2x to the 5th y squared square root x times y. Now this is where I actually, again, multiply my outsides and multiply my insides. And then we'd have to simplify again. So I'm going to have 2 times 6, which is going to be 12, x to the 9th, y to the 7th. Okay, that's going to be my outside. And my inside, I have xy squared. Now I know this y squared, again, right, can come out. So now I'm going to add it to my already established y to the 7th. So it's going to equal 12 x to the 9th y 8 square root x.